Okay, the last but not least project and example for section 4 is talking about scope. Now, talking about scope can get really, really confusing and advanced, so I'm going to keep it really simple for now. This is just an intro class, so I just want to cover the very fundamentals of scope, and that should be okay. So I'm going to show you what my example 5 does. It's a pretty self-explanatory program. It says, please choose from the following options. I can either convert inches to centimeters or centimeters to inches. Well, I don't know how many centimeters tall I am, so let me say 1. And let's see, 6 times 12 is 72 plus 1, so I'm 73.25 inches. That's my height in inches. And it's going to say 73.25 inches is equal to, and apparently I'm 186.08055 centimeters. Well, that was useful. And let me try it the other way around. Let me say, let's pretend I know how many centimeters I am. Let's say I'm 185 centimeters. Says that's equal to 72 point a bunch of decimal places inches. So that's a pretty simple program. So I'm going to open up the code. So I have a show main menu function method, which, as you probably guessed, shows the main menu. That I also have a show input prompt that shows that little arrow thingy. And then I sit there and I wait for the user to type something in. And then the fun begins. So, talking about scope. So, aside from a bunch of reading and writing, there's not a whole lot going on in this program. So the first time I ran it, I said 1 because I wanted to convert from inches to centimeters. So since I typed in 1, and now I know my if-else statements, it's going to skip over all of this stuff. That stuff's not going to happen. So that stuff up there inside of the if command equals 1 is going to happen. It's going to skip over all of that stuff between line 23 and 36, and then finally it's going to just end the program. That's it. So when I type in 1, basically this is what the program does, and nothing else. So what does it do? It says enter the inches, it reads in a double from the user, and then I declare a local variable called conversion, and I multiply inches times 2.54, and then I print that out to the screen. Very simple. Now in the other case, if I hit 2, it's going to skip over this because this if statement would be false, and it's going to basically just do that. So this entire if statement, all the way from line 14 to line 36, in the case that I hit 2, is only going to do those instructions that I have highlighted between line 25 and line 30. So that is nothing new. So what's the point of all this? All this code is absolutely nothing new. The only reason I wrote this code is because I want to talk about scope and explain to you what that means. So I want to draw your attention to lines 18 and 19. So I've declared 2 variables there. So when I talk about scope, scope usually means something like what can I see from here, or what exists here where I am. And there's a word that's pretty important in programming called local. And if we say something is local, it means it lives in the current scope. So the word scope means basically what you can see from here, or what exists right now. So when I'm inside of this if statement, when I'm inside of the begin and the end, I am inside of the scope of this if statement. So that's the begin, that's the end, and that's that block of code. And everything highlighted there is in scope for the if statement. But it's also in scope for the main program. Everything that exists out here in the main program before the if statement executed is also in scope. So I have access to the variable command inside of here, even though it wasn't created inside of the scope of the if statement. So scopes, basically, as we kind of moved on from example 4, we were nesting. Anytime you nest, and this is, to be sure, a nest, because it's a begin and an end that's inside of another begin and end. So everything here is inside of the begin and the end of the main program. So even though we're inside right here, the beginning and the end of the if, we're also inside of the begin and the end of the main. So we're in scope of if, of the first if statement, and we're also in scope of main. And local means the smallest scope. So this variable here, inches, is local to the if statement. It's not local to the main program, it's local to the if statement. So inches and conversion are both variables that are local to that block right there, that begin and that end. Whereas command is local to main, because it's always local to the very first, the very previous begin. So since inches, we look right here, and there's the begin, inches is local to that block of code there. So it's in scope, and command is also in scope inside of the if statement, but these variables are local to different scopes of the program. So this is in scope right now, but it's local to the if statement. This is in scope, but it's local to the if statement. Command is in scope at this point in time. We can see it, we can access it, but it's local to the main program. Well, what is the point of being local? What does that mean? And this is the most important key to what I'm trying to explain in example 5, is this right here. As soon as you hit an end, any variable that was in scope, any variable that was declared local to that block is destroyed. So when we say inches is local to the if statement, and we say this is the beginning of the if statement, this is the end of the if statement, since inches and conversion are both local to that scope, as soon as that scope is gone, the local variables to that scope also are gone. Long story short is, if I wrote a line of code right here, and I wanted to say console.writeLine, and I wanted to write inches to the screen, it has no idea what inches is. The reason is because inches is gone. Inches only existed within this if statement. Since it was declared right here, it was declared within the scope of the if statement. It's local to the if statement. Therefore, the moment that the if statement goes out of scope, all of its local variables get destroyed. So inches no longer exists here. Inches only exists inside of there. However, if I wanted to write command to the screen, I could do that, because command is local to the main program, and the main program doesn't go out of scope until that end is hit. So since my line of code right here is above where everything local to the main program goes out of scope, I can still access it. So that's the first, well, maybe only, that's the first and most important lesson of scope, is that anything local, as soon as you hit an end, anything local to that begin and end is going to go away. So inches and conversion both go away. Second thing I want to call your attention to is line 27 and 28. I have two more local variables, centimeters and conversion. And just like these two variables up here, these variables will be created and destroyed inside of the else if that begins on 24 and ends on 31. So unless this else if block is hit, and unless we actually come into this block of code and create this scope, those two variables will never be declared, and they'll never be destroyed. They'll never be declared in the first place. In the case that we do hit 2 and we come into this scope, they'll be declared here. They'll exist only for these 2 lines of code, and the moment we hit the end of the else-if scope, centimeters and conversion will be destroyed because they're local to this else-if. Notice that in this scope, I have a variable called conversion, and in this scope, I have a variable called conversion. Same type, same name. Now, in the normal world, you can't have 2 variables declared that have the same name, because in a single scope, it wouldn't make sense to have 2 variables that have the same name. Because then if I said, hey, print out command, they would be like, well, which one do you want to print? There's 2 of them, and they have the same name. So that doesn't make any sense. However, with 2 different scopes, the same variable name is just fine, because you can't ever be in here and in here at the same time. These 2 scopes are siblings of each other and can never both exist at the same time. They're mutually exclusive. You can't hit 2 blocks of an if statement at the same time. You can only hit 1. Therefore, having a variable that has the same exact name in this scope and a variable that has the same exact name in this scope coexist is fine, because you're never going to exist in both of these scopes at the same time. So that's kind of it. I don't want to confuse you too much. I just want you to understand that all variables that you declare local to a certain scope go away as soon as you hit the end of that scope. And I don't think that's really crucial to doing any of the assignments that you have for this section per se, but from the very start of the course, at least, people, they want to understand the life cycle of the memory they declare, obviously. And next section, as we get into loops and stuff, loops are other constructs that also have begins and ends. So anytime you have begins and ends, so far all we've had really is methods, like the static void main and these 2 methods I have here. So far we've really only had methods that use the begin and the end, but you kind of want people to know that a variable that is declared within the scope of a begin and an end goes away as soon as that begin and end is over. We're just talking about methods. Like if I could declare a variable here if I wanted to, int x, and the only place in the world that I can use that variable is between there and there. So again, because this variable is local to this method, and it only exists within the scope of the method. So be able to look at a variable declaration, see what the previous begin is, match it up with the end, and then understand that's where the variable lives. And the variable will go away once that scope ceases to exist. Last thought is why. Some people might do this. Some people might say, I'm just going to declare the variable up there. And then instead of declaring it there, I'm just going to use it there. I'm just going to use it there. Right? Now I don't have to declare it inside of these smaller scopes that go away. Now it's local to main. Now it will always be there until the main program goes away. So you might say to yourself, oh, that's great. Now I don't have to worry about my conversion variable going away. And actually that's bad. It's not a good thing. The reason is because this variable has a purpose, and your instructions in your software are trying to achieve a purpose. And when you get to this line of code down here, this is just a random line of code. When you get to this example down here, you have no more need for this conversion variable, right? So basically what you've done is you've made the scope of the variable more global and less local. and that's bad. You want to make the scope as local as possible, generally speaking, because by making the scope of this variable more global, it's just hanging around for a lot longer, and you might not need it anymore. So it's kind of cluttering up it's doing more than cluttering up memory. It's also cluttering up your mind, I guess, as when you're reading what variables you have available, where you are. When you're down here, you shouldn't be thinking about that anymore, because the time for the relevance and the usability of that variable has come and gone. So by making it local here, you create it, you use it, and then it goes away. I guess technically speaking, it might not matter. It might be more of a good design issue to decide how global or local to make a variable declaration. But I would say it's pretty good design practice usually to not make something more global than it needs to be. You can make every single variable accessible everywhere, but that's really bad design. We usually learn that in the first couple weeks of programming, that global variables that are accessible anywhere in the software are bad. So that's kind of everything I want to say about scope, at least in the first semester of programming. In the second semester, I usually go into it more deeply, but for now, just understand that variables are local to a certain scope, and they go away as soon as that scope ends. And in general, declaring a variable local to where it belongs and not making it just globally accessible everywhere is usually a good thing. It's a little more compact, and it makes it so that variables that aren't useful or relevant anymore aren't just sticking around for the remainder of your program. Alright, I'm going to end it there. That's the end of section 4, and hopefully that should be all the information you need to complete your assignment. And that will leave one section left, which is loops and arrays, which is, I think, probably the maybe even the easiest, but certainly the most fun out of all the 5 sections. So hopefully that will be something cool that we can get into next. Alright,